Okay, so hey guys, it's Quinston, and today we're gonna look at Radix sort as an algorithm. Um, Radix sort is one of the most highly optimized, basic, common, sorting algorithms which are out there. The thing about Radix sort, the speciality of Radix sort is that suppose you have an array. Suppose this is an array, and the largest number is of 2 digits. So the number of passes it will take in order to sort the array will be 2. Isn't that epic? Suppose the largest element in your array is 3 digits. Then the number of passes which will take to sort it will be 3. Epic, isn't it? Bubble sort takes much more passes in order to sort an array because it goes through every single element. But this quick, very fast, but it takes more memory. But nowadays we have like lots of RAM and everything, so it can be spent, but sometimes it can't. Anyway, that's not the point. The point is how this works. Okay, so how does Radix sort works? Radix sort takes every last digit and places it in a stack-based system. So suppose 28. It will take the 8 as a reference and put 28 in the index which is marked as 8. Okay. It will take 878 again and place it in the index bucket. So that is basically a bucket. That index is the bucket. So it will take 78 and place it in the bucket above the 28. Okay. Suppose it's 1. This is the fun part. It will take this 1 as the index because that is the index, and I will place it in the bucket marked as 1. So similarly, 92 will go in the index marked as 2, index bucket. 83 will go in the index bucket marked as 3, 7, 0, the 0th bucket, 9th bucket, 12, and that process will repeat again for the first element. Suppose you have 2, again 20, and there's one more thing. As you take the elements out of the bucket, you place them in a particular order in the array. You'll know that when we go through the code. This is just I'm just trying to give an overview of what exactly we're going to do. Don't worry, the code is over here, so I'm not shying away from the code. This is going to be a very lengthy tutorial and we're going to have a lot of fun making it. So let's get to the meat of it. I think you get it. We're just going to repeat that process over and over again until we get a proper answer. And I just want to keep it out there, like let it out there that I'm not going to use a stack because most of the people use object-oriented stacks in order to keep track of radixes. But I'm going to use a two-dimensional array because it's easier, and I just want you to get a feel for what we're doing instead of actually getting into the object-oriented side of things. That's not the point of this tutorial. We just want to know how Radix sort works, and we're gonna do that. Anyway, let's just start with the first thing we're gonna need. We're gonna need a constant variable which has a value of 999, and basically it's gonna be called as infinity. Public static final int and infinity equal to 99999. Awesome. I think I spelled infinity correct. Okay, I did. I just have a thing with spellings. It's how it is, Okay, so what are the things we're gonna require in order to actually implement a Radix sort? The first thing is a matrix. It's gonna be a two-dimensional array which is gonna hold our it's gonna be actually the buckets. Okay, suppose you have the matrix that is going from x and y. The y is going to be our number of buckets, and the x is going to be the stacks of those buckets. Okay, and then we're going to have a bucket counter which actually counts the the bucket counter is basically going to hold the number of values that are actually in the bucket. You'll know when we actually do it. You'll understand it. It's very simple. Don't worry about this. This is a very simple algorithm. It works very well. Anyway, and it's very fast too. So int matrix equals to new int max. So what is max? Max is our length of the obviously array. So int bucket counter is equal to new. Oh shit! Sorry, that was a very bad call. Anyway, so that's what is going to happen over here. Now, what do we do otherwise? So we made the matrix, we made the bucket counter, but it has no actual correct value, so we need to initialize them to our needs. So what do we need? The bucket counter should be equal to 0. So bucket counter. Why do we do that? We do that because we want it to be properly spaced, because we're going to increment each element of the bucket counter whenever an element is put into a bucket with the similar index. Okay, suppose I put 25 in the 5th index bucket, then I'm going to increase bucket counter 5 by 1. Get that? And again I'm going to put another element in that matrix, then again I'm going to do it 2. You know, you get what I'm saying, right? Okay, if you don't, you will when I tell you to use a paper and pen. Yeah, I'm going to do that at the end. Anyway, a bucket counter will be equal to 0, all of them. And why to make a new for loop? We can just make a for loop inside this. So for the two-dimensional matrix, obviously. If you don't know what this is, basically this is, watch the Radix algorithm tutorial. It has extensive uses of infinities and in JKs and all that stuff. In J is less than max, and J++. I just want to let you know that if you don't like this tutorial, then please let me know so that I can improve it, and you know, whatever. But right now we're going to set the matrix to infinity. Why do we set the matrix to infinity? Because that is the only number which is going to be unique. Nobody is going to input 9999 5 times 9 as a number inside. Okay, so you know, you can have a safe number. So instead of 999, you can put a number which is completely different, okay, which nobody is going to expectedly put. So that's the kind of numbers we're looking for. I chose 999 because I'm never going to enter 999. You can use something else. Okay, so that's what I wanted to say. Matrix I and J, because I is the, you know, I goes from, I think, left to right, and J goes from top to bottom. Okay, but so it will encompass all of the, you know, elements. So infinity. Okay, so the next thing which we're gonna do is actually start the algorithm, which is over here. Start, and I'm gonna warn you, this is going to be a very long tutorial. So don't know, if you don't like it, you know, you could just skip to the end and where I, you know, show whatever that's happening. I don't know what I'm gonna do at the end, so I can't tell you right now. Anyway, start, end, blah blah blah. What do we do first? First, we need the length of the number of digits of the largest element in the array. How do we do that? We give int max num. So, and we go through every element, and that's what I'm going to do. For int I equal to 0, I less than max, and I++. So this is exactly what's going to happen. Okay. If max num is less than 2 sort array of I. Wait a second, I didn't give a name to the max. Oh, sorry. It should be initialized zeros. Just remember one thing. If you have min num, if you want to find the minimum number, you're going to give this a value of 9999999, the largest value you can give, possibly for an int. But if you're finding the maximum number, you're going to give it a value of 0. So if max num is less than 2 sort array of I, then what you do? You go max num is equal to 2 sort array of I, and then you print system.outs.println the largest number in the array is plus max num. And when you execute this, yeah, 95 is the largest number, so it's correct. So that's how you find the maximum number. Anyway, I'm running short on time, so yeah, let's just stop the tutorial over here and we'll continue in the next tutorial. So stay tuned for more Radix test sorting. Okay, thanks for watching. Subscribe, like, and share this video, because I wanted to get out to reach a lot of people, because most people struggle with data structures. I myself struggled with data structures, so I just wanted to let people know that it's not hard. Okay, nothing in this field is hard. I realized that very late, so I just want people to know that there's still time. Anyway, thanks for watching. I'll catch you later.